Hi, I'm Mike Springer. I'm an associate professor of systems biology at Harvard Medical School. So first off, what is systems biology? And what I love about it is when I grew up and I told my family, who are all like hardcore chemists and physicists, I was going to do biology, they were like, why not just do stamp collecting? What are you doing there? What's great to me is now biology is at the point, it's not just about knowing what the components are. It's about how they fit together and work together to do things. Just like if you had all the components of a radio, that's somewhat interesting, but how they fit together to actually make a machine that does something. And so what I'm focused on is how these components fit together to do computations, to do things and interpret their environment and respond appropriately to them. So our research it focused in two areas. One is very basic, and there is a subset that's more applied. So first, basic research is actually still essential in biology. And you might think in this day where we know as much as we do, we have genome sequence, why can't we just attack problems like, for example, cancer head on? If that's our real goal to help with human health, why shouldn't all our research be focused on that? And it turns out that while we understand a lot, there's still a lot we don't know. And many diseases, et cetera, are really problems with basic fundamental problems about how cells work, how signaling pathways work, how cells respond to things. And so our focus in lab is really to understand how those things work on a deep level. And so that's one area in the lab. Another is, and this in some ways more applied, is we know many diseases involve the interactions of not just one or two components, but hundreds of thousands of components. And we have a pretty good sense of how to understand things when there's only one or maybe two components that interact. But when you get in this level of hundreds and thousands of things interacting, we actually don't have tools or approaches for thinking about those as well. So we're trying to develop things along those lines, both experimentally and theoretically. Initially, I got into programming actually as a kid in second grade. I had a programmable calculator back in the days of where you have magnetic strips which you'd store the information on. And it was, in some ways you might think for the wrong reasons, it was to program little video games to play in the back of the classroom when the teacher thought we were working on spelling or other exercises. But in some ways, it's actually the best reason, because whatever you do, you do it best when you're really excited about it. And that got me into thinking about programming. And while it's great for games, it turns out it's actually great for many other things. It's great for thinking about the large amounts of data we have in this world. It's great when there's problems where you're not really sure how something works, and you can set it up in the computer and learn from it. So I got into it basically because in some ways, programming, once you get used to it, is fun. So I have a wife and two kids. Currently, they're 7 and 4, and I love spending time with them almost all the time. We love to get outdoors. So one of my early passions was hiking and being out in nature. My oldest daughter is actually named Sierra after the mountain range in California, which I grew up spending many, many nights in and hiking through many of the canyons in. And part of that is I just love seeing, I think the natural world is beautiful, and I love challenging myself physically, et cetera. But also, the world around us, to me, is a big puzzle, and I love games and puzzles. And science itself is just, it's kind of the biggest puzzle that's out there. You know, when I play a board game, there's certain rules that you follow, and they're fun trying to figure out what's the optimal strategy to take for some game. But the world around us is a big puzzle. We don't know exactly what the rules are, and we're trying to learn them, and based on that, understand how things happen and manipulate sometimes to let us do things that are interesting or cool.